Welcome to Mental Gym. Today we'll be looking at the atomic structure, specifically we'll be looking at the exam focused questions. These are the two critical questions that will be given in the future to help you to answer other questions. So follow through as we tackle these questions. Okay, so our first question says, name and state the three principles that determine the ground state electronic configuration. So we have three principles. That the first principle that we are going to look at is Aufbau's principle. Okay, so Aufbau is just a German word which means building up. Okay, just how we build buildings from low to high. So this Aufbau is, in other words, it means building up. Okay, so this one states to say orbitals are filled from the lowest energy level to the highest energy level. So below is the model that you can follow through and help you to fill in any atom or element that you are given to do this activity. So we have 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. So you have this one 1s as the lowest and this 4d as the highest. So these things are filled diagonally. So here is what you follow, space you follow. So you follow these arrows, you are placing them. Okay. So this is how you feel like that. Okay. So 1s, from 1s you come to 2s, from 2s you come to 2p, from 2p you come to 3s, from 3s you come to 3p, from 3p you come to 4s, then from 4s you come to 3d, 4p, then just like that. So this is what you follow when looking at Aufbau's principle, and it is a straightforward principle that helps us to determine the electronic configuration of elements. Okay. Let us simplify the Aufbau's principle using this model. So this model, I think, is the simplest, better than the other one. It is simple because it is straightforward. So as you look at this illustration, you see the energy levels are increasing from 1s up to the 3s this side. So it is increasing, this is the increasing one. So this is the simplest way you can look at this Aufbau's principle. So if you are filling in, you start from here, there, then up to your highest energy levels. Okay, so this is all about Aufbau's. So the other principle that we have to look at now is the Pauli's principle, the exclusion principle. So I think amongst the principles, this one is the easiest. This one tells us to say an orbital cannot occupy more than 2 electrons. So if you have, for example, an s orbital here, this one cannot accommodate more than 2. So the highest it can accommodate is just 2. So this is the easiest way you can explain all this principle. So an orbital cannot occupy more than 2 electrons. So the last principle that we can look at is Handel's principle. So this principle tells us to say if you have 2 or more orbitals, electrons tend to move to other orbitals rather than pairing up in the same orbital. So for example, if you have the p subshell, if you have the p subshell which has got 3 orbitals, so if you have, for example, 5 electrons, so these electrons will start filling in one by one like that before being paired. So the other 2 will come to pair up like that. So this is what it simply means. So electrons tend to move into other orbitals rather than being paired up in the single orbital. Okay, so now in summary, we looked at 3 principles here that this question is looking for. So we thought of the Aufbau principle, Then we've also looked at the Paulus exclusion principle. We've also looked at the Archimedes principle. Okay, so these are the three critical principles that we looked at. Okay, so you should take time to look at these principles, know them by heart, and these principles will help us to solve the next question. Okay, so without wasting much time, let's look at the other question with the help of these principles to come up with a solution for this other question. So our second question says the elements x, y, and z have the following atomic numbers: 20, 35, 36 respectively. So we are requested to write the full electron configuration of each of the above elements. So let us try to collect the data here. So we have our x, we are told our x is 20, our y is 35, our z is 36. Okay, so now we'll start with finding the electron configuration of our 20. You can pause the video and answer, and then you can compare with whatever solution will give you here on the whiteboard. Okay, so follow through as I give the solution. So the electron configuration of this element, we are going to be helped by this principle, the Aufbau's principle, the one we explained earlier on, to come up with this principle, with this electron configuration of x. So now we are going to put the first model that we use in Aufbau's, which is this one I'm trying to put here. Okay, so we said we have 1s, 2s, 2p, 3p, 3, sorry, I don't need there. Okay, sorry. So 3s, 3p, 3d. Okay, then we have 4s, 4p, 4d. Fine. Okay. So now let us find the electron configuration of this one. Okay. So as I stated earlier on, to come up with the electron configuration, you have to follow this model diagonally. Okay. So this is how you follow up this principle. Okay. And that's okay. So and you must understand that the S copy to this one, subshell carries 2 electrons, then the P has got 6, and then the D has got 10. And if you have the F this side, it's going to have a 14. So let's go ahead and do the electron configuration of our element X. So we'll start from 1x. Okay, so we have 1s. So 1s, and we said it's 2. So we should hit this 20 in order. Okay, so we have 2s. Okay, 2s2. From there now, according to the arrow, we're going to go to p. 2p, 6. From there now, the 2p6, we're coming to 3s. 3s2, then we have our 3p, 3p6. So you can counter check before you go very fast. So now 2 plus 2, that's 4, 4 plus 6, that's 10, 10 plus 2, that's 12, 12 plus 6, that is 18. So I'm remaining with it, and I have my 4s. I can now put my 4s2. Okay. And I have my 20. So you can counter check again to make sure that things are right. Fine. So now, from this information, we are able to collect a lot of things from this information. Okay? So because we say our chemistry is in the last shell. Okay? That's where our chemistry is. Fine. So now we're going to get this information and put it in this folder so that we're able to choose our information that we're looking for. So from this data, we should be able to get the period and also the group. So let's go ahead and illustrate that information in this way. Okay, so let me just use a different marker. Okay, so I'll start with 1s there. According to this, put my 2, and then I'll come to my 2s. I'll put my 2 there, then I'll come to my 2p, and then I'll put my 6 there. Then I'll come to my 3s, and I'll put my 2 and 3p6, my 2, and then come to 3d. I want to figure out that the 3d, why? Because I still have the lowest energy level when you look at this here according to the arrow. So I have first to come to 4s to 4s2. Okay? Which means I'm giving this one 0. So let's counter check if we've done the right thing. So 2 plus 2, that's 4. 4 plus 6, that's 10. 10 plus 2, that's 12. 4 plus 6 plus 18 plus 2, that is 20. Okay, so now, so our last shell is this one here. So that's why I said we must take this way, because this way is going to help us come up or see the last shell clearly rather than that one. That one will either maybe confuse you, but I urge you to use this one so that you can be able to create your information correctly. Okay, so I believe in the previous lecture with my colleague, he did a very good job on this one. Okay, yeah. So from here I'm going to come up with my period and also group. Okay, so what's my period? Okay, so you are right. That's the answer. So my period is this. This is my period. What's my group? You are right. My group is 2. Okay, and we are done. So this is how you tackle this question. This is how you look at it, and it's very simple and straightforward. Okay, and we have our next element, 35. Okay, so let's try to do that. Just on a rough paper, you can start doing it. I believe now the information has, we've gotten the information and the way we're supposed to do this thing. Okay, and I believe you've already gotten it right. Just want to prove your answer. Okay, so element 1. Element 1 is 35. Okay, if you are smart enough, if you look at that 35 and you recall the previous element 20, you just get the exact thing you did there and then press on this one. But I want to show things ordered. So I'm going to put the model that we are using, which is the AlphaGauss. There, we are still using this. Don't throw away those principles. So I have my 1s here, my 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Okay, so that you don't get lost, please, you can include your numbers here now. 10, t. So let's come up with the notation for this element. Okay, so okay, so here is the solution. Okay, 1. Okay, so start 1s, 2, 2s, 2, then 2p, 6. I'm sure you're following and you've drawn those arrows we drew at first. Okay, so let me just show them. Okay, so you like that, like that. Listen, this is the beauty of chemistry. Very nice. Okay, so 2p6, we are coming to 3s. 3s, 2, 3p, 6, then we are coming to 4s, 2. I believe if you remember the previous element, this is 20, counter check, 2, 4, 12, 2 plus 2, that is 4, 10, 12, you have your 18, 20. So we continue from S, we're coming to 3D, and 3D was saying it has got 10. Okay, 10, let's add, we have 1s, 2s, 20, 30. Okay, so from here, you have a 3 to 10 and 4p, so I'm going with 5 electrons. So I'm going to get my 4p, 10, I'll put my 5, because the highest can hold is 6, so I'll just pick up 5 to hit the number I'm looking for. Okay, as we said, let us present this information in this manner. Okay, so I'm presenting it here for, so I have 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 6, 3d. So I have my 3d, and what is my 3d? 10. So I have to put my 10 there. Okay, from there now, what do I have? I have my 4s. Okay, 4s is 2, and then I have my 4p, 5. This is how you present your information using this model. And this model, and it helps you to come up with the period and the group clearly. No politics, no. Okay. Okay. So group and period. So what's our group? Now you have a question. How do I find the group when I have 2 in my last shell? How am I going to find it? Well, it is simple. Just add the 2 powers. Okay? 2 plus 5. What's 2 plus 5? That's 7. Group 7. What's your period? As you can see, it's 4. So this is element Y is in group 7, period 4. Okay, so this is how we come up with the solution of Y. Okay, so let's do the last one. Okay, you can start doing it as I am cleaning my board. Okay. Okay. So I'm looking at my last element, which is Z. Z is 36. It's 6 and you have 85. Why did we have anyway? It's fine. Let's do it again. We want the information to sync, okay? To be known. Okay, so let's do our model again. Okay? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Don't forget your numbers so that you don't get confused when filling up your configuration. So we say this is 2, this is 6, and this is 10, and this is 14. Okay, so let's go ahead and do the notation. So my Z there. Okay, so I'll start with my 1s. 1s2, 2s2, 2p6, 2p6, and 3s2, 6, 3p6, coming to 4s2, okay, 4s2, coming to 3d10, 3d10, coming to 4p6. I think we are right. Let's count check, right? So you can just do all the counterchecks even like that. Are we okay with the filling? Okay. I think we are okay. Okay. So 2 plus 2, 4, that is 10, that is 12, that is 18, 20, 30, 36. Wonderful. So we start now. Let's present our information in this manner as usual. Okay, quickly. Okay, so I have my 1 S2, my 2 S2, 2P6, 3S2, 3P6, 3D10, 4S2, 4P6. Are we okay? Yeah. Okay, let's do a counting. 2, 2, 2, 2. Although this is the wrong way of counting, let's do the right one. Okay, so 2, 4, that's 10. Okay, 12, 18, 20, 30, 36. We are good. Okay, so GP, group period. What's the group? You are right. That's the group we found. What's the period? That's the one you found is the group. So, group, as we said, add there and there. Okay, that is 8. Then, the period is 4. Wonderful. So, this is how you answer these questions. Not complicated, using those principles. Okay, if you understand and master those principles, okay, you can solve or you can find any question that comes in the examination based on this. Okay, so now I think for today we'll end here. Yeah, we'll end here, but let me leave you with an assignment. Okay, finally we have a question on board. Okay, and it is a quiz. So you should be able to solve this question at your own time. Okay, and we have elements A, B, and C. So you should be able to come up with the electronic configuration of these elements here at your own time. Okay, and then in the next session we are going to address them and give you the solution. Okay, yeah, otherwise this is what we have for you. So thank you very much for watching. Please subscribe and like our page, and if you have any questions, please drop them in the comment section and we'll be able to address them. Thank you very much. Hoping to see you in the next session where we'll be looking at the critical topic, which is chemical bonding. Otherwise, thank you very much. Bye bye.